one thing I thought might be worth talking about, which is I added some user-facing guardrails to Crimson generally for two reasons. One, we want to make it hard to accidentally start Crimson OSDs, since it would really complicate a production cluster. And two, Crimson OSDs don't support everything regular OSDs do. So to the extent that we can, it's probably a good idea to guard off those features so that people don't accidentally use them. So to that end, there are two things I did. So the first is I added a Crimson experimental feature flag and a set allow Crimson OSD map flag. I didn't do anything especially complicated here. You have to have the experimental feature enabled to set the set allow Crimson flag, and you can't unset it. Crimson OSDs won't boot at all if they don't see this in the OSD map flag. So that's how that part works. The other feature is Crimson pools. So part of the design here is one day we're probably going to want to be able to mix Crimson OSDs and regular OSDs in the same cluster. So this is on a per pool basis as opposed to on the full cluster. When you can either set the OSD pool default Crimson parameter, which will cause all pools to be created as Crimson pools by default, or you can give it on a per pool basis with a Crimson flag. It disallows a couple of features that Crimson can't deal with, like changing the number of PGs or using tiers. And the main upshot is that Crimson OSDs won't locally create PGs from pools that don't support those. That's pretty much it. I updated the Ceph ADM instructions, at least in the branch that implements these things, to include these steps. So it shouldn't be too annoying for users.
What are you going to do when Crimson starts supporting those features? Like,
change the monitor to undisable them.
Well, sorry, but I mean, is there another set of Crimson's feature flags, or do we have to stick them in the existing messenger bitmaps, or? Are you just gonna be like,
I'm not
it's
going to worry about
Crimson,
that
and
for
so
now.
we're gonna assume they work. They work. Okay.
I'm just curious.
So far, we support. Oh, sorry. Go ahead, Neil.
No, go ahead. Go ahead. Why don't you finish your thought?
When we support a thing Classic supports, we support the current version of it. If that makes sense. So in that sense, we actually were protocol compatible with Classic after a fashion. But for instance, we don't support tiering at all. So when we do support tiering, we'll support tiering the same way Classic does, up to the same feature flag, etc. So I'm hoping it won't be a problem, but this is likely something that's going to have to evolve with time. I'm going to try to push the team to support. Go ahead.
Oh, we don't have a feature that'll recognize, support split pools, because like all OSDs up until now have supported splitting PGs. So, are you just gonna be like, hooray, now Crimson does it, so we let the monitors do it, or?
No, what this does is prevent the monitors from changing the PG num.
Yeah.
Clients
but in the future, you're gonna need to change the PG num, right? Like eventually, Crimson will support splits and merges.
So if we care, we can just condition it on the release flag like anything else.
That is exactly what I was getting at.
Yeah.
Okay. I was getting at this.
Anything that coarse?
Yep.
Go ahead.
No, sorry, I was just going to say that, we're very clear about which features we are supporting for Reef, and what we expect. So we could potentially use the release Reef flag for some of this.
All right.
So basically, the release flag would just mean different things with respect to supported features between Crimson and Classic.
Yeah.
And for fine-grained stuff, we might eventually have to add a special feature flag. We'll figure that out if it comes up. But I'm hoping that it won't.
Cool.
Do we have these features which are supported or unsupported documented anywhere? I'm just looking at the upstream documentation.
Not really.
Oh.
So
the only things supported
for Reef,
are...
Right? So maybe when we have our Reef documentation come out, we'll have this documented?
So basically, we're not going to so much publish what's not supported as we're going to publish what is supported, which is replicated pools on BlueStore without tiering or changing the pgnum. Does that make sense?
Yeah.
The other thing I noticed, Sam, was that there was a global config set global that you're doing. So it's not an OSD level thing, it's a global setting.
For enabling Crimson, yes, it's a cluster-wide setting. But all that setting does is literally permit you to turn on Crimson OSDs. The
Okay, so
pool flags, however, are per pool.
Okay, so there's not like you can use regular monitors running Reef with Reef Crimson OSDs?
Oh, yeah, you have to.
Yeah, there is no dependency as such. So okay, that's good.
Wait, hang on. Maybe I misunderstood your question.
No, and there's no monitor-related Crimson flag changes that we're adding here, right? It's all OSD related.
Well, these are all monitor flags, or monitor. They're OSD map flags that get set by the monitors, if that makes sense.
Correct, yeah.
And the monitor doesn't care about these except insofar as it sticks them into the OSD map and polices which ones are allowed to be set on Crimson pools.
Right.
This will likely have to get more sophisticated for S release, but this, I think, is enough to get us started. I am, however, interested in anything you guys think I missed or that I might want to address sooner.
I'm curious about the tautology testing. So now all your Crimson tests will have to set this, or maybe we could have something globally for the Crimson suite that sets this. Otherwise,
The branch has the relevant changes.
Okay, perfect.
I'm pretty sure they work. They worked 3 weeks ago when the lab worked. The lab will have to work again before we can actually merge this because I don't want to break the tautology jobs. But the short answer is when you're creating the cluster, you set this experimental and recoverable data corrupting features flag and the set allow Crimson flag and the monitor config that causes pools to be created by default as Crimson pools. It also, it does one other thing, the Crimson pool thing. It disables the autoscaler. One way people were shooting themselves in the foot was by creating pools and then forgetting to disable the autoscaler. Since Crimson doesn't support it.
What about the balancer?
Or that one. Wait a minute. What's the difference?
The autoscaler is doing the pgnum management. The balancer is changing mappings for the PGs.
That should work.
Okay.
Yeah, the Crimson can deal with peering just fine. It just doesn't have split yet.
Okay.
I mean, the Reef release is, to be clear, unstable. The documentation says that you should expect bugs up to and including data loss. So it's possible that I missed something there, and if so, that's okay. But that's the intention. The intention is it should just work.
Exactly, and the other thing is that the balancer is on by default, so if there are issues, you probably will be catching those in testing.
Or so we devoutly hope, yeah. If not, users should. Or people doing performance testing, I should say, since no one should be using this in production. The intention is for S release to be usable by enlightened, adventurous users for real use cases, but only people who know what they're getting into. So we'll do a lot of testing next year.
Cool, I think this all sounds great to me.
Cool. That is all I had.
Do you have any more questions or any more topics?
I actually wanted to bring up one more topic other than this, which is conditional debugging in Ceph or maybe intelligent logging. I remember discussing it a month or two back, but I thought could be another. This could be a best place to bring it up again.
Yeah,
Basically,
sure.
the intent of talking about conditional debugging or intelligent logging is that, I mean, we do have a lot of debug levels in Ceph, but I mean, we do have to change it when we are troubleshooting a situation. But with conditional debugging or intelligent logging, I mean, I think developer level changes would need to be done so that whenever there's a situation or whenever there's a trigger, the debug logs can be triggered or enabled automatically for a condition, and then they could be toggled off again if a mechanism could be devised that could be very useful in troubleshooting and root causing the problem whenever it happens. Because in some situations we know that uh, we require the debug logs from the time when the problem happened, but many a times we don't have or find those debug logs because they are by default not enabled. So this could, I mean, uh, does
Yeah.
this sound like a feasible idea?
So this is definitely an interesting idea, and this resonated with something that Radek brought up, and that was in context with an upgrade. I think Brad, you are familiar with this one. The bug that we were seeing in our Giba cluster in the LRC. So every time we were doing an upgrade, there were randomly like one OSD that would hit a crash, and then it would just come back up fine. And we were never able to reproduce that kind of issue in our pathology testing or anywhere else. We also realized that that was a real issue by means of telemetry, that there were some real users hitting it. So he proposed something like this. So the idea definitely seems useful. How do we implement that is probably the open question.
That
He
was
suggested
revolved.
something, yeah.
That revolved around the inability of the Gibber cluster to capture a core, which is not something that Ceph can do anything about.
Yeah.
So the
Oh,
challenge would be specify.
sorry, go ahead.
Oh no, go ahead. I thought you were done.
No, I just wanted to say that there the idea was like, we knew that restarts were the issue. So something like Ceph ADM that was doing the restarts for the upgrades could potentially, have some kind of hooks to enable and disable logging. But then again, that would be blanket, right? So it's not, you can imagine in 1,000 OSD cluster, we are trying to enable logs for all the OSDs one by one. So it was not logistically feasible. So I am Sam. You can chime in.
Yeah, so the challenge is predicting ahead of time where you'd want to put a trace point like that. So an obvious example is a thing happens somewhere in an IO, and you wish you had logging from the beginning of that IO, right? So it's easy to create a branch that does whatever custom logic you need to detect the condition you're interested in and change the debug logging. But that means pushing a point release before you can actually do that, right? It's not clear to me how to allow you to create a trace point like that without going as far as the I'm forgetting the name, the Linux kernel injectable trace point concept, which would be an interesting idea if someone wants to do a prototype of that. But does anyone remember what system I'm talking about? There's a thing in the Linux kernel where you can inject, and other things, where you can inject code into a running process, and it'll check a condition and emit traces conditionally. No one? Let me see if we Google it.
It's a D-trace?
Yeah, I'm aware of it.
Dtrace, yeah, thanks.
Yeah, I think I heard of dtrace from Brendan Gregg before.
The thing
talking
is,
about
we
this.
already have an advanced, we have an enhanced log that we store in memory, and if we get a core, that gets dumped. If the daemon crashes, that gets dumped. And I believe there's a command that allows you to dump that.
That's
Core.
true, but it's much less powerful than dtrace.
I'm not saying it should be a substitute for dtrace. I'm just saying that exists already. I'm wondering how often it gets used. The thing is, somebody would have to be proactively. Like, are we saying this all has to be automated, or there's no user input?
No, it's more like, let's say you want to dump some specific debug line, but only for very specific IOs, contingent on some parameter in the IO itself. Dtrace would actually allow you to create a trace point with conditional logic. That's basically arbitrary to the parameters being passed in. It's shockingly powerful. To do something equivalent to that in Ceph, you'd have to create a branch,
You
like
could probably
a
do
newly
something
built
like
branch.
You could probably do something like that with a system tap.
System tap. That's, yeah, sorry. Yes, that's what I was thinking of.
Yeah, well, that facility already exists, but that would take would have to be a advanced user that would be able to do that. But I suppose we could come up with some system tap scripts. But yeah, once again,
Garth, maybe you have
relies
a motivating example.
I remember this in RGW actually as well, where multi-site in one of the earlier situations when it was during a customer situation when we saw that IOs from one side to the other were not, I mean, some objects were not getting replicated from one side to the other, and maybe we thought that we would introduce conditional debugging. This was discussed with, I remember Matt Benjamin before as well. Uh, he's not here. So, but yeah, I remember thinking about this from RGW multi-site point of view as well, where we could have conditional debugging, where we could know that there are some conditions that are triggered in code where we know that objects are not why would some objects not be replicated from one side to the other? That could help us understand.
I mean, there are, this could be thought of it in different ways, like case by case. Like, sometimes there are invariants that are getting broken, and then some things can be thought of unacceptable values. Like I can take the example of the dupes issue that we saw. So we had a bug where a data structure called the dupes in the PG log was just growing infinitely. So you can imagine that if we had some sort of threshold, which could have been a very conservative threshold, that we start to log things like, okay, if you go above this threshold, we are going to aggressively start logging things, right? But then it has to be very, case by case basis. And similarly, for things that end up in crashes, we could end up logging things at the whatever the in-memory default log level is, so that when we have a crash, we get something useful out of the backtrace that gets captured.
Yeah, I think this certainly would be helpful on a case by case basis, where, I mean, depending on the situation, before the crash, if some more higher level of debug logs could be dumped,
Exactly.
I mean,
so
we
that
do
we
that.
will know.
Right. So sometimes even that is not enough, right? We still are asking for a core dump, or we're looking for further logs and stuff. But probably if we go by inspection, we might be able to get something more useful out of each crash, given that we have these crash dumps that get collected, and there is a log snippet that also gets collected for all crashes.
Yes, I remember a lot of times when troubleshooting a lot of problems when it was discussed that we need debug logs from the time when the problem actually happened. But in many situations, since in a lot of production environments, the debug logs were not enabled and we could not find the root cause easily and then need to do a lot of troubleshooting further on. So that's how the idea
Yeah,
came to mind.
this is Gaurav. This is because we're caught between two worlds. We're caught between a world that says we don't want any debug logging because we don't want the overhead involved, and we don't want to store huge logs. So we don't want huge in-memory logs because it's too much of an overhead. We don't want the impacts on speed from having to log all this data. We don't want the large logs on disk. Then on the other hand, you've got somebody who says when Ceph crashes, there's not enough information to be able to debug it. So we walk a fine line always.
Yes, that's when we thought. That's when we thought if logging could be, I mean, if we could devise a mechanism where it could be made intelligent, we would certainly have more information on a conditional basis.
But you
Right.
can't
So
log
do you have?
It would be an amount of
Yeah,
information equivalent to a Ceph developer. That's the problem. If we knew that the
like
condition was problematic, we'd have either fixed it or asserted. So the fact that the system continued running at all means the developer who developed that system didn't think of it.
so like we want to have logging in the times when it's useful and not when it isn't. And we do make some efforts in that direction, but we mostly don't know when that is. So the harder part is identifying a condition that needs logging and generating it that when it's still useful.
I would say it's the other way around. We actually have tons of those. It's every assert in the code, right?
Well,
Every assert is,
okay.
we claim that if this condition is violated, a very bad thing has happened. Whereas what you're observing is that there are cases where a bad thing happened and then a long time later,
Yeah.
a crash or something happens, and we don't know what happened back at the original point. So for a system to notice when it happened and go, oh, this is something I should turn on logging for, it's equivalent to knowing that a bug happened, right?
Yeah, right.
That's a lot of intelligence to expect from an automated tool. Something like SystemTap might allow you to, after the fact, inject tracing so that when it happens again, you can get information without having to make a new build, which might be interesting. But even so, you'd have to reproduce it a second time.
Yeah, that's the point I'm trying to make, is that you're kind of asking us to make debugging redundant. You know, we no longer have to debug a problem because we always know exactly what happened in the lead up to the problem, and we have, you know, every piece of information that's possibly gatherable. And that's possible to do, but and you could probably do that now, just turn on all logs to their highest level. But your client's not going to like it.
I mean, if this is something where you have specific things that have occurred that were problematic, we have done things like say, okay, we've detected a condition like there's a stuck operation. maybe we should do something like dump out all the operations that exist, or that are like dump out the operations that are stuck and what state they reached. Um,
Yeah,
a
and
lot of
that's
that we
why the
sort of
heartbeat
tried and then
timeout
backed off
exists.
on, but
That's why things like the heartbeat timeouts exist too.
yeah.
It might be
And like,
good,
we
Gaurav,
got the
to
op
like
tracker and the OSD and the MBS so that you can like say here's what's stuck and what sort of where it's at. Um,
it might be worth keeping notes when you hit conditions like this, and then you could present them as like, I don't know, these are general categories of things that are happening, and then we can brainstorm good ways to attack them as a group. Like maybe a bunch of them are all about RGW multi-site. It might suggest a really specific kind of instrumentation that would be helpful at RGW, if that makes sense. I'm
Yeah,
not sure if there's
certainly.
any.
I think, yeah, that would be good, and it would be good to identify the conditions in the first place that could be problematic, where uh, could do something. It's definitely a point. I think point to consider about feasibility as well, where to do, and it's like a lot of times. I mean, we might have to identify a lot of conditions, or maybe one simple condition that could help us understand when, or maybe just like you mentioned, Sam, right? Maybe identifying an assert where things went bad. There would be a lot of conditions like that in the code, but yeah, need
Yeah,
to identify a problematic one would be difficult until it has
there's,
happened
all,
already.
there's also the question of what level do you go to. I mean, users aren't going to like it if we fill up their var petition automatically under certain circumstances. Um, so always a delicate balance between not enough logging, too much logging. That's why the whole logging subsystem and various logging levels exist to provide that functionality, but it's a manual process, because if we do it automatically, we can go from very few logs where a gig for your logs is plenty, to a situation where a gig is not going to last more than half an hour, 10 minutes. So, yeah, these are the problems
I
that
mean,
need
we
to
could
be
alert the
addressed.
user in some situations where we could definitely alert the users in situations if that at a point if just in case if we had conditional debugging, we could alert the users that there's some condition or some trigger that happened in the code which actually resulted in generating a huge amount of logs and then
How do you
turns it off.
alert them? Via the logs?
No, maybe.
Well, hang
From
on.
my, from my experience, all users will turn that feature off.
That's
They don't
that's
want to
not
go
even
into.
that's not even the problem. We do that all the time, right? Every time you hit an assert, it kills the process and dumps all the logs. The problem is that if no one, the problem is that it can't be done generally. There's no magic code you're going to write that's going to allow the OSD to know, or RGW or whatever, to notice a bad thing happened that the developers didn't think of. That's not generally possible.
And on top of
So
that, Sam, when we hit
Greg
an
is,
assert, the number of log lines we dump is capped.
well, so hypothetically we could dump more, but that's not really what I'm even getting at. The point is that all of those things are specific things that were created one at a time by a developer who identified an invariant. We didn't write a system that generates asserts. We wrote them individually. So I think Greg's right. Most likely, the problem is that whatever system you've been hitting these issues in, you're just hitting an issue with fairly poor visibility in the first place. And the answer is to think carefully about the nature of the problems you're hitting and why they're hard to debug, and then think of an actual subsystem you can add to that component that will make those problems in general easier to debug. Things like the heartbeat timers in the OSD, or the op tracker that just tells you every op that's currently alive is blocked on. Things of this nature. But exactly what the answer is will depend on the specific problems you're hitting. You're not going to write a general component that solves this across all such problems. I don't think.
Yeah, there's also the sophistication of the user that's trying to debug a problem. Like some issues are pretty transparent to a developer or somebody who has a high level of debugging experience, and some aren't. And for someone who has very little debugging experience, they're all pretty opaque. The other thing is some of the tooling has a tendency not to work, like core dumps, for example. People disable them, and even when they're not disabled, they can hit conditions, especially on systems that are running Ceph daemons, or a lot of Ceph daemons, where they'll hit an killer condition and they can't dump out the core. So, we face those sorts of things as well.
Yeah, and the same thing that I was talking about, like, users tend to turn off those kind of, even the op tracker, there have been so many users actually turn it off.
Exactly.
They don't want the extra cost.
Yeah.
So you cannot generalize a solution like this, I think.
No. We could go to the trouble of developing an automated framework that, dynamically adjusts log levels and does X and Y, and then find out that 90% of the user base just turn it off, disable it.
I don't think 90% of the user base turns off the op tracker. So the fact that people can turn it off, I don't think invalidates the idea that, again, just to grab the example where I've gave, if the problem is that objects aren't reliably getting synced, then adding a watchdog that allows you to dump the current state of all moving objects would be a relatively low cost intervention that would allow you to gain a great deal more information when the problem comes up. And I think that's probably what, like, the flavor of the answer will have to be.
Yeah, and that's a single case rather than a comprehensive all-encompassing.
I'm arguing that there is no comprehensive all. It doesn't matter how sophisticated the users are or how much disk you're willing to spend. Short of actually just turning all the logs on all the time, no.
Yeah.
So targeted ones are really your only option. I will say that there is one possible thought, or this sort of triggered one concept. Right now, we assert on pretty much every invariant, but some are more fatal than others, and it might make sense to add a utility in the code that allows us to dump the core memory, the core log lines, the in-memory log lines to log, instead of killing the process. That might be an interesting middle ground. Just a thought.
Under what conditions would we do that, though?
This is specifically in a scenario where a developer is writing a component and identifies an invariant and is like, this is an invariant which, if it does get violated, I want to dump the logs, but I don't want to kill the process. Yeah. It is not an automated system that would identify these things, but it would be a tool developers could use to give themselves more information.
And that would be a slow evolution as the code base changed to use that system. I like that too.
Brad, I remember a situation in the monitor as well where I remember there was an issue in Luminous and Nautilus where
I remember which one you're talking about, the DB corruption one. Yeah, those are the hard ones, right? I mean, like,
you're expecting us to, and that was demonstrated not to be a Ceph issue. It was external. So you're expecting us to generate information about a external situation that's impacting us. Like, I don't.
That was a RocksDB one,
Yeah, and in that situation, we were.
I'm not actually familiar with it.
There was a situation where the RocksDB was getting corrupted by something to do. It was never positively identified what the actual issue was, but it was somehow corrected and just went away. And we were almost certain that the database was being corrupted under Ceph. So the container system or the storage system, something to do with containers or RHEL or storage, was corrupting the RocksDB database. We detected the corruption, but by the time we detect the corruption, all we can do is crash. There's nothing we can do about why it got corrupted.
So to expand on my point before, the intervention I would suggest in a scenario like that would be exploring RocksDB's own APIs for dumping checksums associated with the little file thingies and things of that nature. Doing that on mount or unmount might give you a way to detect corruption between monitor starts. And that's kind of what I'm getting at. Even in this scenario where it clearly wasn't a Ceph thing, there are sometimes visibility things you can add that would give more information. It probably wouldn't have been worth it in this case because apparently it was super obvious that it wasn't us. But if, for instance, this went on for a long time, that would be the class of intervention I would suggest here. Does that make sense, Brad, Grov?
Yep. I posted a couple of links in the chat, Sam, where about system tap and user space applications, just in case you're interested. They're not terribly comprehensive, but they might give you an idea.
I've messed with it in the past, I just forgot the name. So system tap is an interesting idea, but not because it'll automatically dump logs. It's a way to take a production running system and add instrumentation to be used in the future without having to create another release. And that is an interesting concept that might be worth exploring.
Yeah, it also, potentially you can set variables in functions and that sort of thing as well. Make an if statement behave differently, that sort of thing. So, it's fascinating in you could ship a hotfix that doesn't even require the daemon to be restarted. Put it that way.
Hotfixes aside, it would allow you to do something like dump all I/O operations associated with a specific RBD image, even if no such facility existed in the code already.
Right. Yes.
So that reminds me, something like Jaeger tracing that Deepika was working on would also allow you to do some of the example that you were giving about something got stuck, got slow in RGW multi-site. So if you can grab traces, if we had the trace points, first place, you could go back and... Exactly.
Yeah, that would be kind of like the op tracker approach, except writ huge and across the whole cluster. And it has pretty much the same advantages. So that would be a great example of a really comprehensive visibility system that would allow you to gain information on a wide class of problems.
Yeah, but I definitely understood that tracing is also disabled by default, and it also has some performance overhead. But
This
I don't
is
want
the
to go in
thing.
circles.
Everything you do will have performance overhead. There's no question about that.
Okay.
And I think the disabled by default thing is more a property of needing to set up the thing to like gather the trace points. We could be better about deploying that automatically with Ceph ADM or something. An interesting idea.
All right, anything else on this topic or anything else in general for today?
Nothing further from my side regarding this. Just was trying to. It's a good discussion.
Yep, thanks for bringing it
Good
up.
feedback. Thanks. Thanks, everyone.
You can call it a day. Thanks everyone for joining.
Thanks, folks. See you next
Thanks,
time.
guys. See
See
you
ya.
later.
Thanks, everyone. Bye.